Well, at least now I can hear all of you, even if I sound bad.
You sounded good to me.
Oh, okay. I just moved to the laptop microphone instead of the earphone microphone. So anyway, I'll be monitoring the Jabber room on my phone. So if anybody has audio problems like I did, then I can just relay it.
So I have no idea whether I actually managed to replace the slides because people don't tell me what they have changed. So I don't know if the compiled version actually has all the latest versions, because I just hope it did it correctly. So I think we are 2 minutes past, so I think we should start then. So this is IPSEC-ME working group. I guess people are hearing me. If not, say something.
Loud and clear, Tero.
Then I have to find the proper window to go forward. The MeetEcho window doesn't work for moving. Next slide. So this is the Notewell, and everybody has probably seen this a couple of times already, and will see it a couple of more times. So the first things, we don't need blue sheets because they are taken automatically, but we probably need some note takers and jumper scribe. So anybody, volunteering to taking notes in the for the meeting? There is already pre-filled stuff in the Codium ID, so it should be very easy, and just write in the stuff that we actually discuss, not or questions and answers and so on.
Right, and I'll be monitoring the Jabber room, so I don't think we need an extra scribe for that.
Okay, but note taker would be nice.
Yeah, even necessary.
Is our normal stuff for Michael here? No, he's not here. He knew not to be here to be able, so he then end up writing notes. And of course, most of the usual stuff are actually also presenting something. All right. We'll probably try to. It's too hard for me to try to take it at the same time, so it would be very useful to get somebody.
I don't think Daniel is presenting anything today.
No, he isn't.
Oh, that'll teach him.
Daniel, can you take the notes?
Meeting without having something to present.
So I'm really bad at taking notes, but I can give a try.
All right, that people can go there and help. That's all. Okay, good. Okay, so this is our agenda. So we are right on schedule. So we have 5 minutes for the document status. Then we have a couple of work items. Actually, the young model for IP traffic flow security is probably it's in the middle of the work item or the new item. I don't know. And then we have a couple of new items. Any comments on the agenda? If not, we go forward. So our status report. So we have one document that is in IETF last call now, IPv6, IPv4 codes. And I think it will be finishing in a couple of weeks or something like that. It's started. Then we have a couple of documents that are still ongoing. The GIC version 2 is got to I think quite a big rewrite, but is still hasn't been getting that much review. I think IC version 2 intermediate should be ready quite soon, I think. And I think the multiple key extensions and those things are, and the liabilities, those we actually have a couple of other sessions, presentations later for the last 2 ones. Or any comments on the current working group status?
Only that the drafting is wrong in the IPTFS, but that's okay. I think everybody gets that.
Yeah. All right. So there's a couple of people in the queue. So Sigado Sako, do you have some comment or question? If you could just unmute your microphone and talk.
No comment.
I couldn't really hear what he was saying. But Paul, yeah.
I think he said that he had raised his hand before by accident or something, because he was there for a long time. Yeah.
Okay. Yeah.
I just wanted to make a quick note, since we're not talking about intermediate, that we have done interop with a number of parties. So I think we're pretty good there for moving the document forward.
Yeah. Go ahead, Valerie.
I want also to talk about intermediate. It's quite ready for last call. It's stable for more than a year, and we have at least 3 interoperable independent implementations. So I think it's absolutely ready for group last call.
All right, good. Yeah, I know that I have actually getting your emails, but I have been too busy with other things to be able to actually go through it and put it forward. So, but I will try to get it after this meeting. All right.
Yeah.
If nothing else.
Yeah, the IPv4 codes thing is the last call is ending on December 1st. So really, in a week and a half or so.
All right. So let's go forward. So then we have a couple of presentations, and let's start with Paul. And I will be showing the slides and just say next when you want to go forward.
Okay, well, that's easy here. Next. Okay, so an update on labeled IPsec. There are just a few minor fix-ups in the text. There's a little bit of added text in the security section, and we added an implementation section, but currently only LibreSwan on Linux has implemented this. So we have implemented it in LibreSwan. It is working with SE Linux as the underlying security system that transfers, that uses the labels that are transmitted. And so for RHEL, for Red Hat, we now have a path forward from IKV1 to IKV2, which is why we wanted to have this. So there's no interop testing done. If anyone else has implemented this, I would like to interop test it. We are using private number 241. And I think it's ready for working group last call. We only had minor changes at this point, maybe to an early code point. But yeah, that's it.
Yes. So which code body this is actually the 241 is in. I just trying to remember what was the code point. Which registry this is?
I don't think we had an early code point yet.
Which registry this code private number you are using is taken from? It's not a notification. This is something I try to remember. Oh, it was a.
No, it's a traffic selector.
A traffic
selector
code.
type.
Yeah, okay. Yeah. So those are expert review stuff. Yeah. So yeah, if you ticket the stable and we can start the last call, then I think we are gonna actually give the, because as I said, there is no official early code point. You just send an email and or request a code point to be allocated, and then because it goes to the expert review and so on, it actually goes directly to and so on. So you can just start that yourself. Sure. But anyway, so any other comments on the labeled IPsec? Has anybody read this document?
We could do the show of hands, but I don't think we really want to.
No, I don't think we don't want to do that, but it would be so bad.
I'm planning on implementing it.
Yeah. All right. So anyway, let's go forward with that one then.
Mm-hmm.
Okay. The next one is IPTFS update from Christian Hopp.
Oops. I clicked the wrong button. Okay. Hi, yeah. So this is the update to the IPTFS draft. Next slide, please. So we published two drafts, one during the meeting after the cutoff, the gate opened. The changes were largely based on list discussions. One of the additions was a clarification that the fragments need to follow in subsequent sequence numbers. We added a zero comp on receive sort of feature, but this generated a lot of discussion. I got a slide on that. And then we published a new version where we removed the zero comp. We removed the IP protocol number assignment. We did retain the payload type, and we made some congestion control changes. I've got another slide on that, so next slide. So the IP protocol number, originally at 108, and Benjamin had said, do the request. Taro said this is too much trouble to justify this. So we do need to have, we don't always have state-based negotiation like IKE. So we're gonna keep the payload type, but we're just gonna have it be an ESP payload type and pick the number 5. This does happen to correspond with IPv5, which is not actually deployed and used, so the number wouldn't actually conflict with anything. It seems that was our backup plan, and it's pretty straightforward. It's not gonna, we don't have to ask anybody. Zero comp receive support. So this is really just about, it's very simple to implement. You can receive IPTFS frames, and it's useful in non-IKE scenarios. It just goes to one of these things where the more configuration you have to get right, the more chances of getting it wrong. So, you know, we saw this as a nice addition. It doesn't, you know, it's not like critical to have it. It just makes it easier to deploy. But so this was controversial, and so we removed it. Next slide, please. So the congestion control, I made these changes to match RFC 5348, which is the reference implementation that's TCP friendly that we're referencing in the document. We identified these changes as good to make in the pre-transport review and during the implementation of it. The primary changes are, before we had this last sequence number, and because we were sending at a fixed rate, we thought, okay, if the sender, you know, if the receiver sends back the last sequence number that it received, you could sort of interpolate the time that you sent it based on the sequence number. This ended up just being overly clever. It also, you know, if people down the road want to do different types of things with the non-fixed time, non-constant rate sending, it doesn't work for that. So it just seemed better to go with what, you know, the standard way to do it, right? Which is what TCP does, and DCCP does, and everything else seems to do, which is that you send a timestamp the sender sends a timestamp, which is opaque to the receiver, so there's no synchronization issues. It's just a number, but it'll be its clock when it sends it, and the receiver then marks the time locally when it receives it, and when it echoes that, and then it puts that value in the echo field and returns it. Along with that, it sends the echo delay. So it did a timestamp when it received, and when it sends it back, it looks at the latest clock and gives a delta. So it sends a delta back along with the echoed value, and then the sender on receiving that echoed value can just take the current clock minus the echoed value minus the delay, and that's the actual round trip time without needing any synchronization. Additionally to that, we added the transmit delay, and needed this because you can get in situations where if you're going from DC to San Francisco or New York to London, right? You've got a long round trip. But if you're going across a data center, your round trip time can be really tiny. But the actual logical round trip time is based on your send rates, right? Because you have a transmission delay. You're only sending packets every so often to match a certain bandwidth. So the transmit delay is the sender of this value. This is saying what that value, what that transmission delay is, and it knows what that is because that's exactly how often it sends a packet. So it just puts that value in there. This can change in congestion control because you might be slowing down. So you need to keep reporting it. So basically, you take these two round trip times, the actual one on the wire, and the transmit delay, which is your transmit delay plus their transmit delay, and you pick the bigger one, and that's your actual round trip time estimate. Okay, next slide. So the open issues from the last meeting were that Yoav had suggested that we should do a transport review. I think that's a good idea. I think that the idea here is that everybody in this room is an expert on IPsec and they can understand the basic protocol here, and it all looks good. But people are thinking, well, we don't really know too much about congestion control, so we need to get a transport review. So our latest version is based on implementation experience. It does work. The previous version actually worked too, but it was just, as I mentioned, it was just overly clever and a little bit restricting. We also had a meeting with David Black from the transport area, and got some good feedback. And he said, yeah, just put the review in, and we're ready to go on this, I think. Next slide, please.
If I can interrupt, we have asked for a transport area review, and it's still pending. It's assigned to Joe Touch, not to David Black, and they still haven't completed the review. So. Oh,
okay. Well, I didn't even know. We should probably, well, if they haven't, have they started? But we should let them know that we did this update to add the TS-val T-echo change.
Yeah, they'll probably should tell them, but we don't see any progress. We only see when they complete the review.
Most of the people, when they start to do the review, they do the latest version anyway for the draft.
Right.
They don't do the next. We didn't request for specific version. We asked for the latest version. So when they start doing the review, they usually take the latest one. But okay, yes, that's email to the reviewer saying that there's a new version might be a good thing if they have already started. But I don't think they. Usually people do it very quickly when they start.
Yeah, but you only asked for it like November 2nd, so it's 2 weeks ago.
Oh, I don't even remember asking.
No, Tero asked.
Oh.
I was talking with other people this, and they were saying, yes, we should do a transport area, and then I just put it and asked for the transport area ADs, and they said, oh, it was just an early review for the transport review, and I did that.
Oh, okay, thanks. So the other notes, we do have an implementation of this we did in VPP, and the IKE changes we did in StrongSwan. As part of that, I did a VPP to StrongSwan, or I made it work together. There was some stuff out there, but it wasn't fully functional. And we do have congestion control support in this, IKE v2 support. And we're in a publication process now, so we have to go through some bureaucracy to actually get it published. But we're hoping to release this next month. And as always, we're open to collaborating in interoperability testing. Next slide. So we think that moving forward, we think that all the issues on the the base document outside of the congestion control have been addressed in this current version. It was really the IP protocol number allocation and that zero comp thing. Now that I know that the transport review is happening, that action is going. So we were going to say, can we do this part of the working group last call, which is pretty normal. Yeah, so that's the question, I guess, to the chairs. Next slide. I think that's the end. Yeah.
Yeah. So for doing this, so for working group last call, I have to read it myself before I can actually see if it actually really. I want to usually read them before I can actually see if it's ready. And when I was actually reading it quickly, I realized that then I wrote this congestion control stuff, and then I realized that I have to ask for the transport area. For the protocol, IP protocol number, as I said, I don't think the reason I was objecting is I was saying that I don't think we need an early version, because we can do our internal testing with just IC version 2 and saying, okay, if you have this thing there, then you can do it. But I think we can still allocate the IP protocol number. I think that might be better if you actually need to have an IP protocol. Of course, what I was saying, we could just use a 0 or something like that, so that ignore the IP protocol number because we know what is in there. I mean, for ESP, we already it's a transport mode or tunnel mode, and the protocol number is for tunnel mode is actually completely useless. It actually is never ever anything else than the one of this, but for a transport mode it is needed. So I was thinking about a little bit similar kind of thing.
So I think that we could do the why don't we stick with the value 5 as an ESP transport payload type, and it's not really squatting, but no one's going to use that because it's allocated but unused. That was our thinking. Actually, I think Lou is in the room. He's co-author on IPv5 work, so he was like, "We'll just use that." So, if that's okay, I mean, we can try to do the IP protocol number, but I don't want to hold the work up on that because it doesn't seem critical. And like you were saying, if people do want to use it outside, we could always do that work. Either way, I think we're just interested in moving it forward. So if you don't think it's controversial, we can ask for the IP, allocation.
Yeah, but I think the IP allocation. I don't remember what the allocation policy there is for normal. Is it actually standardization required or what? I don't think it's expert. I think it's higher bar. So to get it before they actually going to the publication requested and the IANA does the allocation is going to be require early allocation. But of course the question is if it's almost ready, then it's not that far away. But yeah, and of course with the early allocation stuff, it's also that you have to after a year. I think you have only 1 year or something like that, and you have to re-request it and do that kind of things. And we have been slow sometimes, or should I say all the time.
So just to jump in, Ben Kadek as area director, the IP protocol number allocation registration procedure is either standards action or ISG approval. So yeah, it is a
standards action. Yeah.
Yeah, it's a fairly heavy bar, but we can still request an early allocation. And with the early allocation, if it is granted, then after a year we can renew it. Just with the working group chairs saying, yeah, we're still working on this. And after the second year, then the ISG has to approve it. But we tend to be happy to renew them if the draft is still something that we think is going to happen. It's just sort of the need to ask for renewal is a way to make sure that things that are dead actually go away quickly. We don't want some early allocation to linger there forever, but not actually get finished up.
Yeah, so I think there are most of the things I think, because I think as long as we are only using it inside the IPsec, I still don't think we actually need that, because we can always negotiate with IC version 2. If we actually have some other uses for it outside the IC and IPsec, then I think we need that one definitely. And then, but then I actually would want to get more feedback from people who are actually going to be using it somewhere else than in IPsec, because of course there's nobody here who would actually have any comments about how to use it outside IPsec, because I think people here are working on this to get it working on IPsec.
Yeah, this is our motivation for just saying forget it, right? we have people that want to see this, get standardized. So it's it's just easier to go with the flow here, and so that's why let's just do the ESP protocol payload type, right? And like you said, Taro, it doesn't actually have to be an IP protocol number even, right? Because we own the ESP payload type space. So we'll just pick 5, and that way we're picking a number no one's ever going to allocate because it's already allocated. So if down the road somebody wants to do this, they can write their draft that uses it, and then they can do the IP allocation number. They can do the allocation request as a part of what they're doing, and I think that matches what you're saying.
Yeah. All right. Any other comments on this topic?
I'd say that the question for Ben is whether we're going to get slapped down if we do follow this advice and just stick a 5 in there.
It's possible that we will get pushback. I don't have a super great sense right off the top of my head.
I think if somebody's going to comment, then it happens in the late of the ISG process, and then we can say, okay, we allocate a new one. We allocate the proper IP number then. That's our solution in that case. If they complain about us taking 5, then we say, okay, let's allocate a new one. How about 5? Because we can actually retry that.
Right.
So what we can actually do at that point, if we say that the 5 is actually never going to be used, we can actually then later make a proposal to ISG and say that, okay, how about we actually repurpose this number 5 for this use, so that you don't need to change code, and we don't actually, we still get an proper IP allocation number, but so we can go forward.
Yeah, it sounds great.
All right. So anything else here? No, I think we go to the, I'll skip these backup slides and go to the Young model for IP traffic. IPTFS. Okay, go ahead.
Okay, yeah, so this is an update on the Yang model for IPTFS. Yeah, as you mentioned, this is, go ahead, I'll get to that. So the changes since 108, just some reminders. The the objective here is just to get a Yang model to support IPTFS. The approach is that we're going to augment the only IPsec Yang model that we can find, which looks done, which is this SDN IPsec flow protection. It actually works pretty well. There was an open issue with it. It didn't actually work originally because they split the SA database and the policy database, and they put it into ICLIS. So they have 2 models. They have an ICLIS and an IC version. And to use it, we want to have stats and stuff in the SAs. So it wasn't useful to us if somebody using IC couldn't have stats. So we went through a bunch of rounds with the authors and came to the compromise that please just set they have these notifications for the ICLIS mode to implement the ICLIS mode. And so we asked them to mark them as features. And what that means in Yang is that you don't have to do them. So that means somebody can use the ICLIS and IC model together, even in the IC case, right? And they can put they can use the SA database from the ICLIS model. So that got us to where we needed to be. And so we updated the latest version to refer to the latest versions of those the SDN IPsec flow protection. That one, the version, the base document there seems like it's moving forward. It's getting basic. I think Benjamin he's been working with Tom Petch to get that sort of nailed down, but seems fine. Next slide. I think I might have, yeah. So this is what I just talked to. So it's, they intentionally left the essay database out, and they're missing some information in the essay. Oh, so I should mention also, we put some basic IPSec counters into the IKE model and the essay. And it's just RX packets and bytes received, or octets received, and transmit received and drops. Next slide. So these are the things that we have inside there to configure, which is whether you want congestion control, the fixed size of the packet, or if you want to use PathMTU, or if you want to use that PathMTU to lower it. The bit rate either specified as L3 or L2 bit rate, and whether to allow fragmentation. And you can add to these. Vendors can add to these if they want later, but that's the standard settings. Next slide, please. These are the statistics that I mentioned. The top ones are the IPSec counters, they're very basic. Both of these are also implemented as features. So somebody wanting to do a minimal implementation doesn't actually have to implement either of these. They just have to do the configuration. Next slide, please. So we'd like to, this is pretty straightforward stuff, so we'd like to ask for working group adoption on this. But that's our last slide, I think.
Okay, I don't remember if this is actually, this probably is in our charter, because I think Young models for this, and so I don't think we actually need to do anything for that. And but this is quite new stuff. I don't think there has been that many people who actually read this. So that I would like to, we can have, of course, we can actually start a working group adoption call, and then people will probably, hopefully, read it and comment on it.
Yeah, that probably would be good. It's because nobody likes to read Yang, so if we might be waiting forever. If we do the call, it might cause the people to read it. It's really straightforward. It's it is only a few pages, I think.
Yeah.
It's just configuration and stats.
One of the question I had actually, because this actually I have no idea about Yang, but you were having these things here saying that I assume. These configuration parameters are something that can be changed on the fly. So somebody can go and say that, okay, I want to change the bit rate to be something different, this has actually always been problem with, if people have been trying to use the traffic flow configuration, they have been, okay, how do I actually configure it? Because it's very stupid to put them in a configuration file and reload the whole system. But if they can actually use Yang to change this, I assume these are actually something that are can be changed on the fly, right?
Yeah, usually, I mean, it would be up to the implementation, but usually Yang works that way. Like you wouldn't have, I mean, if in our implementation, if you change the bit rate, we would just change the packet delay.
Yeah. So the question is that actually one of the things I actually had realized that actually having algorithms and that kind of things in Yang also, that would also probably allow them to be changed. Is there actually any way to in Yang say that you can't modify this after it has been installed?
You can't do that in syntax, but you would do it in the description. You could say in the description, if you modify this, it will it will do a renegotiation of the essay or something. You can put that in the description. Yeah,
because one of the things I realized that I didn't see that kind of things in the SDN stuff, and I was thinking about I should probably actually comment and ask them. Actually, somebody should go through the model and check out which of those are something that needs to be changed. But anyway, that's actually a little bit different thing. So anybody has any comments on this document? I guess no. So I think we can actually probably start a working group adoption call for these. If anybody have any objections to do that, I will probably do that one also after the meeting is over. Okay.
So So are we going to do the working group last call on the IPTFS draft too?
I have to check it. I will read it through, and I actually want to. Yeah. Actually, I have to check out the drafts, but the adoption calls are easier. The working group last calls is a little bit more. But I need to check it because probably we can start a working group last call for that also, but we have to check out it first.
Okay, thank you.
All right. And probably, we want to finish the transport area early review first anyway, and see if we get any more comments from there.
One thing that came up on the Jabber room that 4 years ago, there was a draft by Muhammad Bukadir about deprecating IP version 5. And now there's already an ISG statement, so it's back to available. So using it now is squatting.
Okay.
I think that the actual situation is maybe a little bit more settled than that, because it's marked as reserved. It is not marked as unallocated or available for allocation. So it's sort of squatting, but sort of not.
All right.
Thank you.
Okay, so then skip these ones. Next one is Valerie. And this is now moving from the work items to the new work items, something that are not really our charter currently.
Hello?
Hello, yeah, we are hearing you.
Yeah, go ahead, we'll hear you fine.
Okay. So large payloads in IQ2. Next, please. So there is first about motivation. And we have a working draft multiple key E that addresses issues of using large keys and multiple large keys that are common in post-quantum key exchange methods in IQ2. But this draft still limits the size of any single key to 64 kilobytes. And it's the maximum size of IQ2 payload. And if we look at the NIST current state of the third round, so most candidates fit into in this restriction. However, some national regulators, like BCI, still recommends using classic Mac-Elise key exchange with the smallest key size of 255 kilobytes and with more conservative parameters up to 1 megabyte. So it doesn't work with the current draft IPSEC IQ2 multiple KE. So another consideration that we have in mind is that probably with post-quantum signatures, we'll always have either signature size or public key size that would probably exceed 64 kilobytes limit. They, in this case, they wouldn't fit in ours in set payload. So next, please. So what's the goals of this document? The goal is to define a way, some way of using, of transferring specific data blobs in IQ2 that are greater than 64 kilobytes. So these data blobs are public keys for key exchange, signatures, and certificates. And we want to make it backward compatible, and we also want to address reliability on transference at large data in IQ2, and we want to introduce as minimum changes to the current protocol as possible. So next, please. And not a goal. And we don't have a goal to define a generic way, generic mechanism for IQ2 that any payload can be greater than 64 kilobytes. So we don't want to introduce a new payload format. It's just some very specific data block that can exceed 64 kilobytes. So next, please. And the draft currently discusses several approaches, and it is not yet in the draft, but we came to agreement among the authors that the way forward, the best way forward, as we can see it, is the following. So if the data doesn't fit into a single payload, then split data into chunks, each smaller than 64 kilobytes, and put these chunks into successive payloads of the same type. So receiving side will concatenate data that it will extract from this payload. And it works well if a message contains only can contain only one payload. Well, in IETF state machine, the message contains only one payload of this time in the message. So it's true for key exchange and OWLs. It's a single payload. There's no ambiguity of extracting data from them. And it's not true for set payloads because there are multiple. There can be multiple set payloads, and each with certificates. If you put single certificate into multiple set payloads, it won't be possible to properly distinguish between several certificates. But it can be worked around. It's a problem, but not showstopper. And so there is another problem is that all these payloads, if they appear in encrypted payload, then encrypted payload size won't fit into 64 kilobytes. It's clear that it will be greater. So it can be also worked around because the size of encrypted payload can be always deducted from the size of IETF message because it's always the last payload in the message. So it's the length field in the encrypted payload. It's useless. It can be set to say 0 or something like that. It's not needed. So it's not a big deal. So next, please. So this is an example, just high-level example of how it can be looked. So you can see that there are several key exchange payloads that all contain a single, in the IETF intermediate exchange, that all contain a single public key. And note that in the initiator request message, in the responder's response, the number of these payloads can be different. So the size of the key exchange in request and response can be different. That's very well suited for key encapsulation key exchange methods that is common for post-quantum cryptography. And also in OAuth, you can see that we can put several OAuth payloads in each signature and doesn't fit into one. So next, please. So discussion. This approach is simple. It's easy to implement. It's very easy to implement. It doesn't touch IETF state machine at all, and doesn't touch sequence of exchanges. It allows unmounted data to be different in different directions. So for key encapsulation method, it works very well. So the contrast. It does require some tweaks, like handling some payloads differently than others. Well, that is it. And it's also, well, regardless, well, this approach, because it uses the same messages as usual IETF exchange, the size of the message can grow to a very large value. So UDP will probably not be a good choice for transport them. So we anticipate that NTCP will be used in this case, and I think that we address the issue that not the issue, but I think we'll introduce a new mode when IETF will switch from UDP to TCP, and ESP will remain in plain or UDP encapsulation if it if it's possible. So it will avoid a necessity to encapsulate IPsec in TCP, because for performance reasons, it's not a very good idea. So either we do all in TCP, or we do IC in TCP and IPsec in UDP on plane. So I think it will address the reliability and transfer in very large data in IC. So next, please. So the purpose of this presentation is to gauge a working group interest in this topic. So is this problem worth to address? And is the suggested approach reasonable? So this is questions to the group. What about adoption?
Yeah, so if anybody has any comments, come to Q now. For my personal view, I think this is to answer the questions. I think this is worth of addressing, and I think actually it would be better to do some other approach to that. I was thinking about having one bit in the reserve fields of the header to say that this is not the last one, meaning the not the last fragment, and that would indicate whether you need to combine it with the next one or whether it's a standalone. And that would actually solve the problem that it actually would work with any payload type, regardless what it is. And of course, it will still mean that if there's implementations who check the reserve, then barf if there is non-zero values there, then they will barf. But that's happening anyway, because I mean, if you have any payload, that kind of payloads, they will not talk with the old versions that don't support this anyway. So, but that's my comment. So I think you are next.
Yeah, hi. So I think it's worth, as an individual, I think it's worth doing. I think we had previously needs for larger payloads, like with config payload, when we wanted to send a large amount of routes. Well, they're not routes, they're traffic selectors in the config payload, but yeah, the same thing. And we were limited by the 64K, which was okay, but not. What I'm wondering is why not go to the, well, to me, obvious solution of just changing the payload format to accommodate like a 3-byte or 4-byte payload length, and then you're not limited by 64K, and of course negotiate that capability in the initial exchange.
Well, the motivation was simplicity. So this approach is very simple, and it doesn't require any change to payload parsing, or, well, a very little change. So that's why it was taken. But if you want to change a generic payload format, well, it's possible. I agree. It probably was to discuss, but it's a major change to the protocol.
To me, getting several payloads of the same type, and then knowing that when you get these payloads, you have to merge them into a large payload at the receiver end. That's more complex than just having an alternate payload format, but that's probably implementation dependent.
I think it was to discuss, and on the other side, if you want to make, well, it's just one use case, large payloads. The other use case is to make IC messages as small as possible. Well, not for this particular large key exchange method, but using IC for IoT or the like. And we are trying to make it as small as possible. And for this reason, to enlarge a generic payload format so that it will take not for header, not will take 4 bytes, but for example 8 bytes. It's not a very good idea. It must at least support both formats as compact and large and something like that. So
I guess that makes sense. Yeah.
So call for adoption. What do you think?
So let me see. this is wondering if this is not really our charter, but I think we can actually still consider this as part of the post-quantum
Yes.
algorithm stuff.
Okay.
So because it's needed for certain algorithms, so we can actually do this even if it's not explicitly mentioned in the charter. I would really like to see a couple of comments on people, and actually I was really thinking about we should probably have a little bit more discussion about what would be the best way of having pros and cons on different things for the actual implementation. Either having I think 3 octets is too short. I think 4 octet length is needed unless you actually really. But actually, I think actually, if you say 1 megabyte is most of those, then actually 3 octets actually would be enough for most of those, and that would actually mean that even if we actually have, if we ever have more payloads that has more than 3 octet lengths, that means that we have more than 255 fragments or these kind of payloads that need to combine together, which actually start to get really a little bit annoying already. and that's actually one of the question is, if you actually have that big payloads, then I think changing to the payload format would be either better, because I mean if you have to combine hundreds of these, then it gets a little bit annoying.
I think at that point we're using TCP anyway.
Yeah, but we are
Yes.
using of course. But even in TCP, the payload format is still. I mean, if you use this method that we have, multiple of same payloads with maximum length of 64Ks, and we want to send 1 megabyte, we still have what we have. Let me see, 32. Sorry. 16 payloads we have to combine to send 1 megabyte.
Yes.
So, but anyway, so I think we want to get people to read this document. This is so. Do you have the draft that is already that has all the discussion about this?
There is a draft, but it's mostly discussed different various methods, approaches of putting large payloads into IP2. And it is
so I don't think actually it would be ready for the working group adoption for that kind of document yet. I think we would want to see.
We need to update it. We need to update it anyway.
Yeah. But if you actually would take this document, different approaches to the list, and we could have a started discussion on the list about what would be the best of the different approaches and what would be the good things and bad things about those, because people have different views and different. And as I said, there were actually one of the things that people also wanted to see would actually transport in configuration payload. They wanted to transport like whole configuration files, where you have a text file which has the whole configuration, and that can be actually quite big. And that was one of the things that they were saying, we want to use GFK set to set the configuration to all of our remote devices. And then we were saying no. But anyway, so any other comments on this? If not, we move to the next one, which is Valerie doing the encrypted DNS.
Yes. Next, please. So this draft was presented in IETF 108, and since we received some comments, and one comment was complexity induced by mixing attributes in a single attribute format. Well, we checked with doc authors, and they expressed a desire to have a port number to be configurable, and it was a desire to supply a doc URI template. So we issued next new version, which incorporated all this. Yes, next please. All these changes. So there is a new single attribute, new attribute format is the same, but we introduced 6 different attribute types with the same format for so that each type of encrypted DNS and IP family is carried into dedicated attribute type. So we included port number in this format, and we remove scope bit because it was controversial, and actually there was comments that it is not okay to use encrypted DNS servers outside terminal. So next, please. Separate attribute types. There is a trade-off between complexity and the size of the message. So we decided to simplify processing so that each encrypted DNS has its dedicated attribute type, and so it's like negotiation. Client includes all the attribute encrypted DNS type it supports, and the server returns back one or probably a few of them, which it also supports. It is configured in DNS. But each attribute type, each attribute can contain several IP addresses. Well, the reason for this simplification, the justification for it, is that in ADD working group, encrypted DNS is mostly considered as equivalent to unencrypted. Encrypted resolvers are equivalent to 53 resolvers. So it must return the same response when whatever encrypted DNS you use. So from this point of view, there must not be difference if, for example, we choose one of the supported encrypted DNS types, and we have the same results. So it's like negotiation. That's why we decided to separate attribute types for each DNS type. And next, please. So port number is included as a comment from doc authors, and it's the same for all IP addresses. And if DNS servers have different port numbers, then several attributes of the same time might be returned. So next, please. And scope bit is removed, yes, by request. It's a comment that client outside of a tunnel is out of scope of the trap. A server outside tunnel. So next, please. So this is a new format. It's the same format for all attribute types. It's very simple. So it contains port number, number of addresses, list of addresses, and authentication domain name. Next, please. And what about doc specific? Doc servers may support more than one template, and the client uses well-known URI recent for to discover these templates. This like shown in this example, and it is covered by in the draft BTV ADD home, and it's just an example, and we will use whatever mechanism ADD working group will choose. Next, please. So comments, questions, and it seems that ADD working group is not interested in this draft because they are more focused on basic ADD functionality. So if IPSECME working group is interested, so it's probably the right time to adopt this draft.
All right, so we have a couple of people in the queue already. Tommy?
Hello, can you hear me?
Yep.
Great. Yes, thank you for presenting this. I mean, definitely the document seems in better shape than it had before. I like some of the changes. Regarding the relationship with ADD specifically, I actually would like to urge us to not necessarily adopt or move this work forward until more has been done in ADD. Specifically, some of the mechanisms we're looking at there would define ways of getting the other information about essentially the alternative encrypted DNS protocols in other ways, let's say from being able to look up a DNS record that lists out the details. And it could be that all we want in the IKE information is just what is the name that we need to authenticate of the resolver. And the other details like the alternative protocols or the ports could be handled in a more generic mechanism. And that may not be the case, but it may be the case. And I don't think we should jump the gun here and end up having a conflicting approach. I think in general, what we could do in IKE should align with whatever we end up putting into DHCP and RA for bootstrapping trust in the same way of the encrypted resolver name.
So you suggest to wait?
Yeah, but as mentioned in the
keep discussing it,
Jabber
but
room,
let's not adopt it or progress it until we get a bit further.
Okay.
Yeah. Yes. So as mentioned in the Jabber room, the existing trust is different from, or trust posture is different for DHCP as opposed to IKE. In IKE, we already know who the gateway is, the other gateway is the peer, whereas in DHCP, we're just sending in out a broadcast and waiting for some information there. So the challenges are different.
Yes, and a VPN is certainly more of a trusted source, but that doesn't mean that we should have divergent approaches to how we communicate the details. And also, if we design this right, we may not need to have an IKE extension for every little detail of encrypted DNS protocol changes that come up. And it looks like the way this is going, you know, if there's another protocol after DOQ that comes up, we would have to keep adding more and more extensions.
I think that was Paul next, I think.
Okay, so I'm actually a little concerned about the fact that there's not a certificate payload so that you can actually get the certificate of the DO or DOT server from basically a trusted IKE v2 peer, because that would be a really good way of kickstarting that trust relationship to the name server. If it's a public one, then sure, there might be public discovery mechanisms you can use. But if it's like an internal one and there's a split VPN, so there's a split DNS as well with an internal only zone, and the name is internal only zone, and how you reach that name without actually getting to the name server. So I think there's definitely an additional bootstrap problem that might need to be resolved, and that might require actually sending some kind of cert payload for the TLS connection or the HTTPS connection.
Maybe.
Hello, can you hear me?
Yeah.
Hello.
Yes.
Yeah. Hey. Yeah, I would like to respond to some of the comments from Tommy and Walter. The first one is that this draft does not define some of the mechanisms for discovering, for example, the DOH templates. It's pretty much relying on the work that's happening in AD, and we are not defining any IKE v2 extension for conveying the DOH URI templates. The only reason why you see, in addition to the resolver name, that the IP addresses and port numbers are being conveyed is to avoid any DNS over 53 lookup. That is to basically avoid a clear text DNS lookup. That was the reason for adding the port numbers and IP address. But we can definitely wait for the outcome of the discussions that I think many of us, including Tommy, and we are actively participating in at working group. The other one that I wanted to bring up was the comment that was brought up with regard to using private certificates. What we have been assuming in this draft is though the DNS server is going to be hosted on private IP addresses and it will be within the VPN provider's network only for the VPN clients who connect to it. It can still have a public certificate but use private IP addresses, and the VPN provider can still use ACME and other protocols to have an public domain name and get a public certificate, but make sure that that internal DNS server is only reachable by the VPN connected clients and not by anybody outside the network. So we did not see a reason for sending the certificate fingerprint back to the client for authentication purposes.
Okay, so I think that was the last from the queue. Our AD was saying that we have to recharter anyway for this work, so we can't actually just adopt it yet. So we have to, but actually that doesn't mean that that actually gives us some time. The question is that do you actually want to add recharter to do this kind of work also? And I think there is, we probably want to go to list and ask the list that whether people actually think that this is item that we should be adding, and we probably want to get some other things also. Perhaps we have to check out what other. I think currently all the other things that we have are already in the charter, but this one isn't so. But there might be some other things that are not. So we should probably ask those questions at the same time in the list. All right, so if nothing else, then we go to the next, which is Valerie. Revised cookie processing in IPv2.
So, revised cookie processing. Next, please. So this is just a reminder slide that reminds how cookie is used in IP2. So if a responder feels that it's under attack, it returns a notification containing cookie, keeping node state, and initiator resends its initial request, including this cookie, which is an opaque blob for initiator. And then ICAUth, in ICAUth, the initiator's request message is fed into the auth payload calculation to see that authentication that the client is authenticated, and no changes was introduced by the attacker into payload. So next, please. So we encourage a couple of problem scenarios. So this is the first problem scenario. Consider the network that is very bad and introduces long delays and high packet loss. So initiator first sends IKSA init request. Responder responds with cookie. Responder feels that it's under attack, and it responds with a cookie. But this message containing cookie request is delayed for quite a long time, so that initiator times out and resends its initial request without any cookie. At this point, when responder receives this request second time, it doesn't feel that it's under attack because situation has changed, and it's just a response with IKSA init response, and considers the IKSA init completed. And this response is also delayed. And after some time, the initiator receives the initial response from the responder containing cookie, and it resends rec2, including this cookie, into the request. But this request get lost in the network. After some time, the initiator receives RESP2 response, and also considers the IKSA init completed. So at this point, both initiator and responder think that IKSA init has completed, but they have different view on what was the most recent request message from initiator. So initiator thinks that it's rec2, while responder thinks that it's responder thinks that it's rec1, and initiator thinks that it's rec2. So as a result, since these messages will be fed into our payload calculation, the authentication will be failed. The next, please. And a very similar scenario, but a little bit different. It's also a very bad network with long delays, packet loss. In this scenario, responder feels that it's under attack in both cases, but it changes cookie generation secret between receiving the first and the resend IKSA init and resended IKSA init request. So it generates different cookies. And at the end, when IKSA init is completed, again, initiator response have different views on what was the most recent request message from the initiator, because initiator thinks that it contained cookie C1, while responder thinks that it contained cookie C2. And again, authentication will fail. So next, please. What is the source of the problem? The source is that IKSA init request can be sent several times with different content and depending on the responder state. And since it is later fed into the house payload calculation, if IKSA init is completed when initiator and responder have different view on what was the most recent IKSA init request, so in this case, authentication will fail, despite that all the credentials of the initiator and responder are correct, and if the network is better, they would complete, like I say, ours without any errors. So next, please. So what is severity of this problem? Well, from the first glance, there are a lot of preconditions. So network must be really bad with high probability of packet loss and delay, and responder state must be changing quite frequently for this to happen, either changing cookie generation secret or changing responder's mind whether it is under attack or not under attack. So it's probably rare in normal conditions, but we run into this issue during stress tests, stress tests, and from our observation, it was up to few percent, up to 5%, depending on the network and on the responder of assays that failed due to this problem. And the worst thing that it's the diagnostics is absolutely unclear for the customers, because they see that authentication failed and they started checking their certificates, pre-shared keys, and everything is correct, but there are messages that authentication is failed. And I think that it's a protocol flaw. Next, please. And so what's the proposed solution? I think that we can work around the situation by excluding cookie from the IKSA init request message if it is present. So every functionality that is tied to cookie, like anti-clonage token, will be retained, but it is not fed into the house payload calculation. And next, please. So how this can look like? Initiator sends IKSA init request message. A responder that supports this revised cookie processing includes cookie notification containing cookie and an empty revised cookie notification, just to indicate that it supports this extension. If initiator doesn't support this extension, it will respond as usual. It will ignore a revised cookie, and everything will work or doesn't work as it currently happens. But if initiator also supports this extension, it will place a cookie into the revised cookie, into the new revised cookie notification in resent request message. So this will indicate, this will an indication for the responders that initiator also supports this extension. So next, please. So if both peers agrees upon using this extension, then the cookie processing is changed as follows. So no change in cookie functionality. So the very first thing that responder must do is, if the message contains revised cookie notification, is to check if the cookie data is valid, correct, and if it doesn't, it behaves exactly as requires RFC 96 IQ2, and request another cookie. Probably in most cases request another cookie. What is change? What is the change? The change is in the output load calculation. So it is calculated according to the RFC 7996, like initiator's signed text is a real message one, nonce are data, and marked ID for initiator. So the change is that real message one is modified before using this formula. So if revised cookie notify payload is present in real message one, so it is removed as if it wasn't there. So the next, please. This is how it is done. So you can see that on the left, the message that was really received, real message one. So revised cookie notification is removed, and two fields are updated: next payload like header and message length. A very simple update for this field. So is this updated message is fed into the house payload calculation. So next, please. So that's all. So questions, and is this problem worth to address? And is this approach reasonable? And what about adoption?
Paul, go ahead.
I had a question. So if the client initiates a IKSA init, and then it doesn't get a response, it tries again, and then eventually it will abort the exchange and try a new exchange, it will likely create a new KE payload for that new IKSA init.
Yes.
So
but
then
it's not the case. It's not the case that we're considering here. It's just here client doesn't timed out so that it completely
right. So
it's just resends this message.
The case you're fixing is the retransmit case, right? Where it's retransmit.
Yes, retransmit case, exactly.
But it's not fixing where the client restarts, which if you're talking about so many seconds of delay for this to happen, like, you know, I think like things like iPhones stop after 10 seconds and do a new one. So do you really hit this case or not?
If you restart, then you also have the different SPIs.
Yes,
so that
it's different like SPIs, different SA, so it's all bit different. I consider only the case when, initiator first sends initial IKSA request. If response doesn't appear within, say, 1 second, it resends its initial request just exactly as it is. And after another second, it resends it again. And it's repeated few times before timed out and starting a completely new IKSA. So it's just a retransmission. So if he doesn't receive a response, you resend your request.
Right. Okay. Yeah. So I think I'm a little bit in agreement with Yoav on the chat, where he's like, is this case worth fixing? Because you're already assuming that there's so many packet loss and such slow network. Even if you get a tunnel up, what's left to do with it? It's going to be unusable.
Well, I don't know. Again, it depends. We did encounter this problem in stress tests. Of course, it's stress test. It was about several thousand or 10,000 of I connections that simultaneously I clients, not I clients, but emulated I clients that simultaneously at the same time going to the responder. And the network was also emulated. It was especially emulated, but not very good network conditions with long delays and packet loss. And we did encounter the problem in these conditions. I understand that in real life, it is very rare. So that
Right.
thousands of initiators and attack a single responder with a bad network. But, well, my reason for this draft is that from my point of view, it's definitely a protocol flow. So if protocol ended up with timed out, or I don't know, or for example, temporary message, but it's ended up with authentication failed. If a customer it's very unusual. What's happened? My certificate is okay. My shared key is okay. Why authentication failed? So if timed out is okay, it's a network condition. Temporary message, so bad ICV check is also okay. Something's problem with network, but authentication failed. It's something problem with my certificate, and that is for customer. It is very annoying, and it's very, I don't know. It's not a good thing. Protocol reaction must be different in this case.
Sure, I understand. And one other minor suggestion, which I'm not sure if it's worse or better. Instead of having the notify in the IKSA init, you could also, of course, encode it as part of the cookie and say, like, if the cookie starts with this string, then you can do something with it too. Then you don't have to send a notify. But I don't know if it's worse or not.
I thought about this, but I decided that it's more hack than to use a notify.
Compatible because somebody might be using exactly that beginning of the cookie when he's sending.
Yes.
If you call it revised cookie string or something.
In the queue. Scott, then, I guess, or was it actually yeah, Scott? So, Scott, you can just unmute yourself and start talking. Or not.
Okay, I was in the queue to channel Scott's message from the Jabber room. Wouldn't having the implementation select a fresh IKE SPI when it changes cookies solve this problem without the need for protocol change?
Actually, it is responder who changes, who generates a new cookie. So responder just responds to the request, and it cannot change IKE SPI. And for initiator, it's quite possible to receive several different cookies because it's in the draft. Sorry, it's in the RFC, IQ2 RFC. It's quite possible situation when initiator receives first cookie request with cookie 1 and then cookie request with cookie 2. And it just resends it because it's a opaque block for the initiator. It's just sent it back. So I don't think it's possible.
Actually, I think in this case, where you actually have a cookie and you change the secret, I think most of the cases actually the responder cookie, because if this is the stateless thing, the responder SPI are going to be different, because this is sending a SPI, responder SPI with 0, and he's responding with some SPI.
Yeah.
So I think in this case actually would be actually detected by that, because whatever SPI he's going to be using here is going to be matching whatever cookie he actually sent. And actually, I think the cookie usually has an SPI, SPIs in it there, so it actually is.
As far as I remember, 0.
Yeah. Well, actually,
because
sorry.
there's no point to generate SPI for responders because it's stateless.
Yeah.
As far as I
Yeah.
remember.
But here when we get this in. Actually, yeah. So we actually create the state here when we actually get this one.
Yeah.
And yeah, actually, yeah, it's still a problem. Yeah, I don't think it actually solves the problem. And there have been comments about in Jabber that the revised cookie is probably, hopefully, only just a placeholder, not the real name. But anyway, so this is not in our charter, but this actually I think this is a small change in some sense. So we had a long discussion about this earlier when this problem was found out, and we discussed about what to do with that. I had another proposal, and I think it's actually about the same. So next question is what to do with this document. And does this actually go into this minor modifications, or do we actually need to recharter for this? So that's for the Ben.
Right. I think that this would fit into the general maintenance, small topics sorts of things. I don't feel like we would need to recharter to do this.
All right, good. Then we have to discuss about this. So I will probably take it to the list, and then if the list is agreeing that we should actually work on this, then we should start probably working on this. But I think we want to verify that on the list also. All right, so the next one is not Valerie.
Oh.
And Paul, go ahead.
Okay. So this is work mostly done by Stefan Klaassen and Anthony. Next slide. So the current problem that we are trying to fix is that an IPsec assay is typically bound to only one CPU, and so when you have a big pipe and you do 10 gigs or more over that pipe and you enable IPsec, then suddenly your performance drops dramatically to 3-4 gig or something. And so if you got a NIC that can even do more than 10 gig, then you see a significant drop in performance. So what we really want to do is see if we can use multiple CPUs in a way that makes sense performance-wise. Additionally, if you do QoS services, then you would need different IPsec assays to get the right traffic on the right assay. And also, if you do more than one IPsec assay, so if you do one IPsec assay per CPU, then you run into the issues that if you have multiple IPsec assays with the exact same traffic selectors, that some implementations might delete the old ones because they think the duplicate means that you should delete the old one. So and also we wanted to do some negotiation where we basically say how many of these parallel IPsec assays we want to use, so that both parties know beforehand and don't try to set up too many of them. So that's basically what we set out to do. So next slide. So one thing that's needed is some more clarification in how to handle IPsec assays that have identical traffic selectors, and to make sure that people just don't delete the old ones, and assuming that they have been replaced. And we are suggesting notify payloads to convey some information about these duplicate IPsec assays that we're going to install. So one of them is the numQ1, which is basically telling or negotiating between the peers how many duplicate IPsec assays you want, and then you can put one on each CPU and keep them sticky on that CPU. And we have a QInfo notify for the QoS case where we think that some information needs to be conveyed, like this is the IPsec assay for this specific quality of service. So next slide. So there's an implementation in Linux. The draft has links to it. This was done by Steven Glaser. And this includes where you can do an on-demand acquire message per CPU. So you can, if you have 16 CPUs, you can say you can do up to 16. But if there's only 2 CPUs sending traffic over the tunnel, you could just set up 2 IPsec assays. There are some catches there, because if you do something, for instance, like a ping, it might switch to another CPU, and then you end up setting more assays than you really need. But so there's some tuning that might work, or sometimes it just might not work, that they are on demand and you'll fire most of them up anyway. But we thought it would be good to at least have the option to slowly bring them up on demand. Then there's LibreSwan and a StrongSang implementation. Anthony has done most of that work, so they're definitely not independent implementations at this point, I would say. But they do give the proof of concept that this is working. So next slide. So this is a benchmark. You can see black is the unencrypted traffic, depending on how many CPUs you use. Red is basically the universe where we live now. If you set up one IPsec assay, you're limited to about 4 gigs of traffic, regardless of how many CPUs you have. And if you set up multiple tunnels, multiple IPsec assays per CPU, then it basically climbs up linearly. So this is a big advantage. If you have like a single IPsec assay to a data center, and you basically want to use something like this. So next slide. Some issues that we could use input of the working group for. One is there was some talk about how to negotiate the exact number that you want to do, because a CPU is not a really specific measure of computational power. So just saying like I have 4 CPUs doesn't really also tell you how powerful they are. Maybe the other end will only do 2, and versus the 4 on the smaller device, that's good. So so initially we put in a preferred and maximum, and then they can pick the highest one that fits within the max. That's the highest preferred one that fits within the max value. We're also thinking of whether there's use in signaling on sort of a CPU ID, so that both ends can sort of keep sync about which CPUs to keep something on. But that is also conveying some internal state of these machines, so we're also a little uncomfortable doing that. So we're not sure if there's value in doing this or not. Then for the QInfo, if it's only QoS, then maybe we don't need a sub-registry. But if this is going to be used for more than one type of information, then probably we should give a way of structuring this information so that we can standardize some of this information being exchanged. There's also some corner cases where, like for instance, if you agreed to do 8 IPsec assays and you've installed 7 and both sides initiate for the final slot, then you end up with 9 IPsec assays. So should the draft say something about that, or do we leave this as a local implementation where maybe one end will delete 1, or maybe they'll just leave 9 running? A bigger issue is IPsec rekeying, because that changes the spine numbers, and with some of the hardware support that's being used here, that might actually change, for instance, the CPU that it's bound to. So it might switch to a different CPU because its spine number changes. and so then you run into issues where one CPU is like underutilized and one is overutilized. And then there's also issues with NAT mapping. And NAT mapping is the same thing with RSS. Those values are hashed. So if the NAT route in between changes the mapping and changes the hash, then it might also change the affinity or the queue where this work will end up on. So next slide. So some hardware-related things that maybe we should or should not dive into in the draft. So the assumption is that the sender has no issues to pick which CPU it will use. It's only the receiver that needs to distribute the load properly, and that's where the real hardware support is needed. So most network cards these days support RSS. Usually they only support it for UDP and TCP. They don't support it for ESP, even though you can sort of sneak in the same offset because they're using it for basically creating a random hash. And since for ESP the SPI number overlaps with the UDP port number, you can use that too because it's also random. But some hardware implementations now support RSS natively for the ESP protocol. And then there's also the N-tuple support, which is also usually not available for the SPI selector. They usually also only look at the port numbers and the source and destination IP addresses, but not go deeper into the packet to look at the SPI to select this on. So that would be nice if it's available, but that's usually not the case. And then we see that like virtual NICs are also starting to play in this space and trying to aggregate things and bind multiple virtual NICs together. And so they're also playing in this space where we have sort of a virtual hardware solutions. And next slide. So I mean, for us, this fixes a practical problem. It's like we need to bring up the performance of of a tunnel between two endpoints where you have where you don't have thousands of SAs, but you only have one of them. So this is one way of solving it. And so the question is, does the working group think this is a good way of doing it? It sort of requires hardly any protocol changes, just like some fine-tuning and telling people how to deal with duplicate IPsec assays. So we're interested in both hearing from the working group and hearing from hardware vendors to see if they're looking into this problem too and getting us the right access to the hardware to start using their hardware. And then if you do one more slide, there's a bonus slide where it explains some of the current Linux-based commands where it's doing some of these things. So that's roughly it. If people have some implementation-specific questions, it should probably be answered by Stefan or Anthony.
So shall we go to the questions, Valerie?
It's not a question, it's a comment. I think that it's very interesting work. And we discussed with Paul and with Anthony and with Stefan in Montreal, I remember, and in general, I support the job will be adopted or will be requested to be adopted. And so I'm ready to review it. And I think that we discussed with Paul about the general approach of negotiation of these things in IQ2, and I'm glad that so the draft didn't go into too much detail on the hardware and internals specific. I think it's quite a right margin of not to go into. So that's why I'm against CPU ID. Well, it should be discussed, but I think it's too specific. But some negotiation must take place, and so I support the draft, and we'll be ready and happy to review it and participate.
Yeah, we would definitely like more input from people about the discussion of like, things like a CPU ID, like is there much to be gained, or is that like local implementation details that should not be exposed, or that has like little value? I think that's a good discussion to have on the list.
Okay, next, Christian.
Hi. So this reminds me of the new ESP work. I wonder if this is came out of that.
So no, this was actually it predates that actually a number of IETFs. Yeah, some of it can solve similar problems, but we found at least that the new ESP work is trying to do a lot more, a lot of different things. It's trying to do multicast and a whole lot of other issues that we fear will take a lot more time to get into a further stage than just getting this out. And this is like a concrete problem, right? Like people have a connection to a data center, they want to encrypt it and they can't. So we're hoping to do something quickly and smaller instead of waiting for ESP v4 to come out.
Yeah, it definitely seems easier to get through. I just as an implementation point, even without like an RSS support, just having been in like VPP or whatever, if I'm receiving and I can fan out based on the SPI, even on one CPU, right? I can do 40 gig on a single core if all I'm doing is looking at the SPI and then immediately handing it off to another core to do decrypt and all that, right? So this is even useful, I think, without hardware support. I think you can probably get up to 40 gig just doing the initial filtering in the SPI. So I think this is good stuff.
Okay, then I had some comments about, actually I was asking, I understand the num preferred max is probably per IKE configuration, right?
IPsec, because you could have multiple tunnels where you want 16 spread out. Like let's say you've got your data center tunnel and a management tunnel. You don't want your management tunnel to have 16 either if your production one has one.
Okay, so okay. And one of the questions I had there, one of the questions I had there that I would actually assume that you actually want to have the preferred to be like 3 times what you have a CPUs, especially because I mean that will actually solve lots of the other cases. It solves the corner cases. It doesn't matter if you have 8 or 9 if your limit is 24 and 25, and it solves the problem of hashing, because if you have lots of those and randomly hashed, they will spread out with all the GPUs. Otherwise, you have to have a problem that you have to allocate SPIs so that they actually hash into the certain, CPU, which might make it very difficult if you don't know how the hashing is done in the hardware. So I think it would be much more interesting to just say that, okay, use the big enough number so you get like 3 or 4 SPIs or SAs for each CPU, and it will still spread out the load evenly. And the question is the QA info. I don't, and I mean, if it needs a subregister, then it probably needs to have a standardization way of putting something in there. If it's just opaque stuff for the implementation, for 2 implementations that knows each other, then I don't think we actually need a subregister. But if you need to have a subregister, then we probably also want to specify what's in there, like what's really in there.
Right. So right now the only use we have for it is QoS. So we could tailor it to QoS only and have it specifically for that. But we're wondering maybe other people have other bits of information that is useful for them to inform the peers of for this. So if nobody comes up with anything new, maybe we will just reduce it and say like we'll just do a specific QoS one and no. So then it would be like QoS info specifically.
Valerie?
Well, it's just a comment, not about this draft, but probably more about its just some association. So this draft is concerned with high performance issues for IPsec. And actually, if you send very small packets, like YP packets with high rate, then overhead that ESP implies is very high. And even if network is fast, you will lose quite a noticeable percentage of its performance. And so that I think that IPTFS can be seen as more generic mechanism of not only for traffic flow confidentiality, but also for packing a few smaller packets into one ESP packet that will improve performance if packets are very small. So it's probably just consideration for Christian that it is not only for traffic flow confidentiality. It has other applications. It probably was mentioned in the draft. Just a comment.
Yeah, that's true, and we had that too on our list of similar work that's being done right now. So yeah, if the new ESP could do something as well, where it can like sort of group a number of small packets together into one, and do that based on like similarly to how modern kernels or NIC cards do this with GSO or other features, that would be great to have. But that would be a much more substantive change than doing this.
Fred haven't read the draft, so this could be a stupid question, but what does it do that RFC 6311 doesn't do?
6311?
6311 allows you to have parallel assays.
Sorry, say again?
6311 allows you to have parallel assays with the same selectors, but...
Right. So I mean, so 7296 also allows that, but this is, you're giving a little more information as to why they're being used, so that both sides know that they're going to, that you want them, and also the point was to negotiate how many you want. Like what we wanted to avoid was a situation where one end goes and installs more and more and more until they get TS unavailable because the other end is tired of installing more of them. Mm-hmm. And so we were hoping that this would like make it clearer from both sides that they can sort of expect how many they will have. So it's from an IETF point of view, it's not a big change. The bigger change is actually at the kernel level, where you're making sure that certain IPsec assays remain on one CPU and doing all that work.
So how do you handle the asymmetric case where one side has like 8 CPUs, the other side has 6?
And Stefan can correct me if I'm wrong, but currently we install all the inbound assays because you have to. But we only install one outbound assay per CPU. So if you get multiple ones, then you just don't use half of them.
Means that the other end doesn't get the benefit of having multiple assays because you are not using them.
Yeah, but that one is the one. So that one is the one that has presumably the bigger CPUs anyway, right?
Yeah. So on the 8-way machine, you'd have 2 cores that never decrypt because the assays are not used on the other side.
Valerie, are you still in the queue or are you?
Right.
Okay, Christian.
Is the Is the QInfo sort of an idea of like you want to maybe pick certain CPUs based on the, you're saying like this is high priority, like voice traffic, and so please give it to an unloaded CPU. Is that? I can't hear you.
Sorry, I was probably muted. We don't want to go into the implementation itself. Like, it's just to negotiate and say like, this is the quality of service. VoIP super important, and how you deal with that on the other end, it's up to the other end. But like at least you have two different IPsec assays to encrypt like your bulk unimportant stuff and your super important stuff.
Yeah. Okay. So this reminds me of in routing we have admin tags, right? So it's like coloring, where you don't assign, you don't standardize the semantics of the value. It's just opaque. So yeah, this makes sense to me for sure.
Yeah. So in the most
leaving opaque.
Yeah, in the most simplest version, we just sent the QoS bits around, right? Like, what is it? 6 bits, I think.
All right, so I think that's it for that one, and then we move to the IETF1 graveyard, which is not our working group item because it's talking about IETF1, even if original first version of the agenda was talking IETF2 graveyard by mistake, but that was fixed. So, Paul.
Yeah, so funny enough, next slide, yeah. Funny enough, even though it has not been adopted yet, if you look at the IETF108 action items for the chairs, it says perhaps go to working group last call. So apparently the chairs were jumping to make this happen. Anyway, so only a very few small changes were made. It was mostly the text from Sean Turner to make sure that we were not saying anything that either IANA or IESG couldn't be instructed to do. So all the work has really been done, and I think we should just get it done, or we should just drop it. But like, it clarifies the IANA registries. It adds a deprecated column. I think it will make sure that people who are implementing Gang won't start implementing all this old stuff anymore, because it's clearly deprecated, and think it's very useful to do. It's also just really nice to have an RFC number where you can point to people and say like, don't use IETF1. So
the last question was, last time we were thinking about whether this should be a working group document or a short, because I think our charter do state that we have the IETF1 stuff also, but so if Ben has any comment on that, or do we actually do this? I think that's a working group item. Is this actually okay for a working group item, or should we take this an AD Spencer?
I mean, if we need to bend the interpretation of the charter to do this, I think this is clearly the right place to do this work. So let's just do it.
I will then make a working group adoption call then for this. I think it's something that we should be doing. And yeah. All right. Any other comments on this? If not, then if anybody out there, so Christian has something, or it was still leftovers from the previous one. All right. So any other items in last 6 minutes we have still left? I don't see anybody jumping into the queue or going to the jobber or anything like that. So I think that's it. So thank you for the presentations. I will try to, as I wasn't able to collect all the the action items that I was supposed to do. So if anybody has any action items I should be doing, send me an email after this meeting. Remind me that this was something that we agreed on, because I most likely forgot most of the things that we agreed on here. All right, I think that's it. Oh, Christian is still. Oh no.
Bye, everyone.
Yeah. Okay, I think that's it. See you next time.
Well,